Let's see how we can generate sine waveform and find its RMS value in Google Sheets. We have the Generate Sine Waveform and Find its RMS Value Google Sheet open, and it has the data template we require. In column A, we will give x in degrees. In column B, we will calculate x in radians from x in degrees given in column A. In column C, we will calculate sine x for x in radians given in column B. In column D, we will calculate A, sine nx, where A and n would be taken from I1 and I2 cells respectively, and x will be taken from x in radians given in column B. This is a more general form of sine function. In column E, we will calculate the RMS of sine x calculated in column C. And in column F we will calculate the RMS of A, sine nx calculated in column D. So to get x in degrees, we want x to vary from 0 to 720 degrees in steps of 10 degrees, that is, a total of 73 values. We will use the sequence function for this. So we will write equal to sequence rows will be 73, columns will be 1, start will be 0, and step will be 10. We see that we get x in degrees from 0 to 720 in steps of 10. Now, to get x in radians, in column B, we will use the radians function in cell B2. Which converts an angle value in degrees to radians. It takes angle as an argument. An example is shown. For our case, we will write equal to radians A2. Let's close the bracket. Let's autofill the data. We see that we get x in radians for x in degrees given in column A. To calculate sine x in column C, we will use the sine function, so we will write equal to sin. It returns the sine of an angle provided in radians. It takes angle as an argument. An example is shown. For our case, we will write equal to sin x in radians, that is, B2. Let's close the bracket. Let's autofill the data. We see that we get the sine x values for x given in column B. Now to get A, sine nx in column D, we will first have to give the values of A and n. For now, we will give A as 2, and n as 1, so we will write 2 in I1 cell, and 1 in I2 cell. To calculate A, sine nx, we will write equal to A, that is I1. We will lock this I1 value using F4 a function plus F4 keys as the case may be. Because we do not want this I1 or the value of A to change as we drag the formula down. Multiplied by sin. Open the bracket for sine function. Now angle nx, so n is I2, again we will lock this I2 using F4 a function plus F4 keys as the case may be, since we do not want this I2 or the n value to change as we drag the formula down. This multiplied by x which is B2. Let's close the bracket. Let's autofill the data. We see that we get A, sine nx values in the D column. Now to calculate the RMS of sine x, first let's see what is RMS. It is root mean square, that is, square root of the sum of the squares of the values divided by the number of values. So, to get the sum of the squares of sine x values, we will use the SUMSQ function, which gives the sum of squares. It takes value 1, optional value 2 and so on as arguments. An example is shown. For our case, we will write equal to SUMSQ. C2. Actually, we will not use C2 because this is 0, instead we will start from the next value, C3, to C74. Let's lock this range, as we do not want the C3 to C74 range to change as we drag the formula down. And let's close the bracket for SUMSQ. With this we'll get the sum of the squares of sine x values. Now, to get the count of the sine x values we'll use the count function, so we will write this divided by count, which gives the number of numeric values in a data set. Again, the range will be C3 to C74, and again, it will be a locked range, because we do not want this range to change as we drag the formula down. Over this we will have to use the square root function. The square root function is SQRT, which returns the positive square root of a positive number. It takes value as an argument. An example is shown, so we will write SQRT, and close the bracket for square root function. Now, let's drag this formula down. We see that the RMS of sine x is 0.707. We will copy this formula for RMS of a sine nx. In cell F2, we will write equal to then paste the formula, and instead of C3 to C74, we will write D3 to D74, that is, the a sine nx values. We will get the RMS value for a sine nx. Let's drag the formula down. We see that the RMS value for a sine nx when a is 2 and n is 1 is 1.414. Now, if we change this 2 to 0.5, the RMS value won't change because it is independent of the n value. Let's change it back to 1. RMS value is dependent on a value, so, if we change 2 to say 1, RMS value will change to 0.707. Let's change it back to 2. Now let's create a graph for this, so let's head to the Insert tab. From there, we will click Chart. We get the sine x and a sine nx waveforms. In the chart editor, if we go to Setup, we can change the x-axis from x in degrees to x in radians, so we'll change this. Select the data range, we will select B to B. Sheet 1 B to B and click OK, so, we will have x-axis as x in radians. Now we want to change this label. The title text is x in degrees. In the chart and axis title, we can give title text as x in radians. We see that it is updated to x in radians. Now, we'll go to the setup, and in the series, we already have sine x and a sine nx. We can add the series for RMS values, so we will go to Select a Data Range, and we will select RMS of sine x. that is, sheet 1E2E, click OK. Again, we'll add the RMS value for A, sine nx, so we will click Add Series, then select Data Range, and select F2F and click OK. We see that we will get the RMS values for these two. Now, to change these RMS lines to dashed lines, we will go to Customize then Series. In the chart we will click RMS of A, sine nx. In line dash type, we will select the dashed. Again for RMS of sine x, we will select the line dash type as dashed. So we will get the RMS lines as dashed lines. We have the sine x graph which has an amplitude of 1 and A, sine nx which has an amplitude of 2. For sine x, we have 1, 2 time periods. And for A, sine nx also we have 1, 2 time periods. Let's close this chart editor for now. Let's shift this chart and adjust the chart a little. If we change this and to say 2, we see that the A, sine nx graph has changed. For one cycle of sine x, we now have 1 and 2 cycles of A, sine nx. Now, instead of n equal to 2, if we change it to 0.5, we see that for 2 cycles of sine x, we now have only 1 cycle of A, sine nx. Let's change it back to 2. If we change A from 2 to say 0.5, the A, sine nx amplitude changes to 0.5. Also the RMS value changes with change in A. Let's change it back to 2. If we change n to say 0.5 again, the RMS value of A, sine nx does not change because it is independent of n value. Let's change it back to 2. So we have the RMS value for sine x as well as RMS value for A, sine nx. With this, we have successfully learned how to create sine waveforms, and how to find the root mean square value of sine waveforms in Google Sheets. Thank you for your time. Please like, share, and subscribe if this video was useful.